Good morning. My name is Zaid Kayal, and I will be presenting my thesis on adaptive AI coaching for human-centered cybersecurity, specifically in phishing and deepfake scenarios. The rise of generative AI has made phishing attacks far more realistic, scalable, and psychologically manipulative. Since ChatGPT's release in late 2022, phishing incidents have surged by over 1,200%, with nearly 74% of all phishing emails in 2024 exhibiting some use of AI. Deepfakes further amplify this threat by mimicking voices, faces, and gestures, such as in the 2024 Erupt case, where a deepfaked video call with financial executives led to a $25 million fraud. And despite over $200 billion in global cybersecurity investment in 2025, most of this investment remains focused on technical defenses, while human error remains the leading cause of breaches. This thesis aims to address that gap by modeling employee behavior under dynamic conditions like stress and message quality, and evaluates whether an AI coach can adaptively reinforce decision making in real time. This research uses adaptive network-oriented modeling, where both connection weights and the speed of learning can change dynamically using first and second order WWW, and HW states. And these networks are defined by three characteristics. The first being connectivity, which states are linked and in which direction, with connection weights. The second being aggregation, how inputs are combined using combination functions. And finally, timing, how fast each state updates based on inputs. The three core combination functions used in the study are the alogistic function for modeling learning processes, the stepmod function for periodic triggering effects, and the stepmod op function for inverse periodic triggering effects. Two models were designed in this study, a baseline model without intervention, and a second model integrating an AI coach. And these models are based on two behavioral frameworks, the COMBI model and the dual process theory. COMBI defines behavior as a function of capability, opportunity, and motivation, represented in the models through states like threat recognition capability and emotional reactivity. While the dual process theory distinguishes between fast, automatic responses and slower reflective reasoning. And based on this theory, the decision to act is given a lower threshold than the decision to report. Model 1 serves as a baseline, showing how employees learn and respond to phishing threats over time. It has three interconnected levels, a base layer in pink with internal mental and external context states that together shape the employee's behavior. It also has a first order first order layer in blue with W states that adapt the connection strengths through learning, and a second order level in yellow with an HW state that controls learning speed based on stress, self-efficacy, and threat exposure. Over time, rising stress levels, state X25, degrades the W learning states, and this model shows how dynamic conditions impact employee decision making. As for model 2, it extends the baseline model by adding an AI coach. This AI coach has the same mental and learning states as the employee. However, its W states are fixed at the optimal value of 1. Two monitor states, X54 and X55, are introduced, and these detect when the employee's decisions deviate from the AI coach's decisions. And this triggers communication through second order WWW states in yellow. These selectively adjust the employee's learning in the first order level without overriding their behavior. Both of these models were run on MATLAB using the same parameters to provide a controlled and fair comparison of the employee's performance before and after adding an AI coach. And the simulation results for Model 1 are shown in this graph. It displays all 33 states across 2,500 time points. most states rise early but begin to decline over time due to the steady increase in stress level X25 seen in purple. And a closer look at the employee's learning shows how the learning initially improves over the first 600 time steps, but begins to decline as X25 continues to increase. Meanwhile, X33, the speed of learning remains below 0.01 throughout the simulation, indicating a low learning speed. As for the base level states, this graph shows how the mental states initially improve but degrade over time. Training, X2 in orange, uh, modeled as accumulated training, a mental state, plateaus early, and stress causes key states like X3 to X6, and control over X7 and X8 to decline over time. And as a result, the secure behavioral attitude X11 drops sharply after time point 1500, falling below 0.1 by the end. For the external states, X13 activates phishing attempts periodically, and this triggers X14 to X17, which together shape the message quality, X18. And with all weights set at 0.5 in the simulation, the quality stays moderate, and belief in message starts dropping early as the secure behavioral attitude increases, but then begins to increase again as secure behavioral attitude decreases over time. Finally, we can see the employees' decisions. X20 report and X21 act. These states are mutually exclusive in the model, and early on, the employee tends to act, but as the learning improves, reporting takes over. But eventually, stress causes secure behavior to decline, and the employee begins to act again after time point 2250, where their belief in message exceeds their secure behavioral attitude. Now, as for model 2, the AI coach's learning states are fixed at 1, so its mental states quickly stabilize at around 0.7, and its secure behavioral attitude stays high and consistent throughout the simulation. This leads to consistent reporting behavior, except for one early deviation where the AI coach decides to act, but this is expected due to initialization. Considering the communication control mechanism previously explained, the AI coach only intervenes when monitor states detect unsafe behavior by the employee. And this is seen by activations in the monitor states early on in the simulation and once near the end of the simulation. Although the employee's W states still degrade over time, they do so more slowly than in Model 1, and this keeps key mental states and secure behavioral attitudes stronger over time. The AI coach clearly improves behavior. Compared to Model 1, the employee reports more and acts less, especially in the last 3 attacks where the employee acted in the first model. Here, the employee decides to report, except for one late deviation, but this reflects the AI coach's selective intervention, which slows behavioral decline over time and supports the secure decision making without overriding the employee's behavior. To further analyze the effectiveness of the AI coach under different conditions, a what-if analysis was conducted, followed by a risk assessment. The what-if analysis tests how the if factors, stress level threshold, which represents stress resilience, and the quality of the phishing message, how these affect the what factors, employee learning, and employee decisions. And each scenario is given a likelihood score, allowing these results to be used later on for a risk assessment. The what-if analysis revealed strong improvements when the AI coach was introduced. Without it, employee learning peaked early between 0.6 and 0.9, but quickly dropped, sometimes even as low as 0.07. This leads to more insecure decisions and a stronger tendency to act rather than report. But with the AI coach, learning peaked higher at 0.95, declined more gradually, and in many cases even recovered over time. Final learning levels ranged between 0.3 and 0.9 at time point 2500, and this shows a clear long-term benefit of the AI coach. While the AI coach didn't entirely eliminate insecure behavior, especially under high-quality phishing messages, it consistently increased reporting frequency and reduced behavioral risk over time. For the risk assessment, each what factor was split into two categories. W states, learning states, value at time point 2500, below 0.35 were labeled as low learning and considered risky, while values above 0.35 were labeled as high learning. As for decisions, the decisions were marked act or report based on the dominant behavior over the simulation with 17 phishing attempts. Each of these what factors were given a risk score ranging from 1 to 5, with 1 being secure and 5 being severe. And we can see that Model 1 had a learning risk of 3.25 and a decision risk of 1.9, while Model 2 had a learning risk of 0 and a decision risk of 0.21. This shows a clear reduction in the risk severity between the two models. And while a learning risk of 0 for Model 2 may appear overly optimistic, this threshold of 0.35 was selected to clearly distinguish between low and stable learning outcomes at time point 2500. To conclude, Model 1 showed that secure behavior declined significantly over time under stress, even with strong initial learning. But Model 2 extended with an AI coach operating at the first order level, demonstrated more stable learning over time and improved decision making. Even in the most challenging scenario, with perfect message quality and very low stress threshold, the employee reported 6 out of 17 attacks in Model 2, compared to 0 reports in Model 1. The risk assessment further confirmed a significant reduction in both learning and decision-related risk, highlighting the AI coach's effectiveness in promoting long-term cybersecurity resilience. Now, while the AI coach doesn't entirely eliminate risk, especially under high-quality or deepfake-driven phishing attempts, it represents a meaningful step towards adaptive, human-centered cybersecurity. And the findings of the study highlight the growing threat posed by realistic AI-driven attacks and emphasizes the need for intelligent interventions that support human decision-making under pressure. Areas for future improvement include adding a decision to ignore state for more realistic behavior modeling, which also helps resolve limitations from mutually exclusive decision structures that we had in our models, as well as empirically validating the model with empirical data to enhance real-world relevance. Thank you for listening.